Hello, my name is Maria, and this summer I worked on creating a historical fisheries sketch time series for the Lake Erie Atlantis model to use, and I worked with Hongyan, Ed, and Doran. So before I tell you about my presentation, I'm going to tell you a little bit about myself. I graduated from Brown University 2 years ago. My background is in geology, biology. For my senior thesis, I used time series to look at event scale plankton blooms and bottom water hypoxia in Upper Narragansett Bay during the summer months for 2007, 8, 9, and 10. So I have some experience working with large data sets and creating time series. That work resulted in this poster that I'm very proud of, and I presented at the New England Estuarine Research Society in 2014. After I graduated, I went on to work with AmeriCorps in a public high school in Chicago where I help students with STEM and Spanish. And working with high school students and trying to motivate them to do science in college really motivated me to follow science as my career. And so I looked for post-baccalaureate opportunities that would allow me to build that skill set that I know that I didn't really finish getting as an undergrad. And so I looked for opportunities, and I was blessed to have the opportunity to come here and work with Hongyan, Ed, and Doran. In 2 weeks, I'm going to be heading up to Columbia, where I'm going to be part of the Columbia Bridge to PhD program, and I'm going to be working with Dr. Sonia Dirman on just looking at the interaction between phytoplankton and their geochemical environment. So my work here has already helped me to find that next step. Okay, back to the summer. So a question that everyone has is, how will invasive species like the Asian carp affect Lake Erie's food webs and fisheries? It's a great question, but I think that in order to really think about how the future might look like, it's really important for us to understand how the present and the near past looks like. So with that in mind, my goal was to create a detailed spatial time series from 1999 to 2013 of fisheries data in Lake Erie for the Atlantis model to use, and really just for future use. So this time frame is restricted by two things. The lower bound, 1999, that's the time when the Atlantis model starts looking at data. And the upper bound, 2013, is the year for which we have the most recent U.S. commercial data for. So this can be expanded if we have more data, but for now, we were just working with those 15 years. So I'm going to give you a quick background on Lake Erie's fisheries. I'm going to give you an overview of my results, how Atlantis will use the fisheries data, some challenges, some recommendations, and next steps. So some background on the commercial fisheries first. So the map that you see here is Lake Erie. The yellow line separates the north and the south. The north belongs to Canada. The south belongs to the United States. Lake Erie supports the most lucrative commercial fisheries in the entire Great Lakes. More than 85% of all the yellow perch, walleye, and rainbow smelt that are harvested in the Great Lakes comes from Lake Erie. The majority of the fish caught in Lake Erie are caught in Canadian waters. The most harvested fish is rainbow smelt in Canada. Like, they really like rainbow smelt. You will see that in my results. Walleye and yellow perch are two of the most harvested species, and they're also very carefully monitored, which makes sense just because so much of them are being harvested. Walleye harvest is banned commercially in U.S. waters, but it is not banned commercially in Canadian waters. The reason why walleye is banned is because in the 1960s, their population really declined due to pollution and overfishing. So every single year, consideration is taken into thinking about how much of the walleye can be harvested, but still allow for populations to remain healthy. If we look at recreational fisheries, sorry, I'm going to go back to that slide. So just from fish alone, the harvest is about 24 million. That doesn't take into consideration that this is a business. There's people working on equipment, on many other things. So that will bring this business to be something like a multi-million-dollar industry. So it's a big deal. If we just look at the recreational fisheries, the Great Lakes, so all the lakes together, just from fish alone, is about $1 billion. If you take into consideration, again, that a lot of people are interested in it as a sport, they come for vacations for it, it's a tourist attraction, that brings about $4 billion from lodging, food, and other things. At this point, there isn't a specific number just for Lake Erie, but Aileen Grafey from Penn State just received the Sea Grant to look into that and to create an assessment of how much money is actually being produced by the Lake Erie recreational fisheries. Okay, so this is Lake Erie map, and here I've divided the lake into different regions that are the different management units. So the first management unit is the Ontario Ministry of Natural Resources and Forestry. This is Canada's side. So they oversee the Canadian side of the lake. The Michigan Department of Natural Resources, that's the smallest part of the entire lake. The Ohio Department of Natural Resources, the Pennsylvania Fish and Boat Commission, the New York State Department of Environmental Conservation, and all of them together have representatives that create the Great Lakes Fishery Commission. And so every single year, they come to, the 5 members come together as part of the Great Lakes Fishery Commission, and they create total allowable catches for species like yellow perch and walleye that are the most harvested species. Again, just to make sure that the populations are staying in healthy numbers. Canada usually gets 50% of that catch, which makes sense because they have about 50% of the lake. The other 50% is given to the United States, which then gets further split up into the different states, Michigan, Ohio, Pennsylvania, and New York. And each state has the power to decide from that catch that we got, how much are we going to give it for recreational fisheries and how much are we giving to commercial fisheries. So every year the different states decide that all of the catch available for walleye is going to go to recreational and not commercial. When it comes to the Canadian side, they don't split it up like that. Basically, if you're in Canada, you can fish walleye commercially or recreationally. So those agencies each have a different way of collecting data and a different way of looking at the lake. So I'm going to show you the different maps that they use for every single data that gets collected. So this first map is the grid that Canada uses for its commercial fisheries. And each grid is about 8 by 8 kilometers. This is the grid the United States uses for commercial fishery. It's a 10-minute by 10-minute grid. This is also the map that Michigan uses for their recreational fisheries. So these first 2 maps are commercial. All of the other maps that I'm going to show you are recreational. So you'll see how much fun I had working with this. This is what Ohio uses, and so it's the same map as the U.S. commercial, but they further split it up into districts. So sometimes they just give a number that belongs to that district. This is what Pennsylvania uses. The yellow here shows the area of Lake Erie that belongs to Pennsylvania. The white line separates the central basin from the eastern basin. Here the yellow line, here the yellow line represents the area that New York gets, and New York records the data based on the different ports that you see here. This is the map for the walleye management units. This is the map for the yellow perch management units, and they look very similar. The big difference is that the central basin and the eastern basin are split up differently. Then we have the eastern basin recreational map for Ontario. They use the same grids as Canada commercial data. This is the central basin for Ontario, the west basin for Ontario. And so when you put all of those different maps together, you get Lake Erie that looks like this. So it's divided into the different regions that we see. So we have Michigan, Ohio, Pennsylvania, New York, West Basin, Ontario, Central Basin, Ontario, Eastern Basin, Ontario. So I'm going to be referring to these locations in my next figures. So Michigan, Ohio, Pennsylvania, New York, Western Basin, Ontario, Central Basin, Ontario, Eastern Basin, Ontario. Okay, so here are some of my results. So this graph shows the aggregated data for 15 years. So in my y-axis, you have the total harvest in thousands of metric tons. This is the aggregate for the 15 years. And in my x-axis, you see the different regions where the number 1 means commercial and the number 2 means recreational. So Michigan 1 would be Michigan recreational, West Basin, Ontario, Ohio, Central Basin, Ontario, Pennsylvania, and New York is Basin, Ontario. And if we just look at the commercial versus recreational, the commercial is much bigger than recreational. It's very clear. If we zoom in into the commercial, we can see that the areas that belong to Ontario, so here the West Basin, the Central Basin, and the Eastern Basin are significantly bigger than the parts for the U.S. When we look at just the U.S. alone, Ohio is the biggest, which makes sense because they have the largest area of Lake Erie. Pennsylvania and New York are not 0, but they're just so small in comparison that you can't really see them in this graph. If we just look into the commercial for Canada, we can see that the top 3 harvested species are rainbow smelt, yellow perch, and walleye. And I mean, the amount of rainbow smelt that gets harvested, it's a little ridiculous. It's a big number. If we look into the commercial for the United States, we see that yellow perch are the top harvested species. If we take a step and just look at the recreational, we see that Ohio is the biggest, and I think this can be because of two things. One, again, they have the largest area of the lake, or two, they just collect more data than every other part of the lake. So this is recreational data, which means that they give surveys to fishermen, they get those surveys back, and they process the data. So if they're getting more data collected, we're going to see that in their results. If you just look at the recreational alone and take away Ohio, just so that we can see the other states, so this is the same in X and Y axis as the other graph. Here the number 2 means that this is recreational. We see that walleye is the most harvested species recreationally, which makes sense again because if it's not being harvested commercially, all of that total allowable catch is going for recreational, and people are looking for it to harvest it. The next species is yellow perch and then steelhead. And so a quick summary of these results is that Canada's commercial harvest is much bigger than the U.S. Ohio has the biggest recreational harvest. Rainbow smelt, yellow perch, and walleye are the most harvested species commercially and recreationally. So it makes sense that walleye and yellow perch are being sought out for management purposes. One thing that I didn't come across when I was doing literature reviews was that white bass and white perch are also very important species. They're the top 5 of all the harvested species. They make about 23% of all the harvest. The recreational numbers might just reflect the amount of data that is collected by each management unit. Okay, so now you might be asking yourself, how is Atlantis going to use this information? So this is a quick background on Atlantis. Atlantis integrates physical, chemical, ecological, fisheries dynamics into a spatially explicit 3D dimensional domain. So it was a model created in Australia in 2004. This basis is from oceanography, but we can create and change different parameters so that it can be applied to freshwater systems like Lake Erie. And within the model, there's a fisheries sub-model that uses the information that we give it to really just look at the fisheries dynamics. And so it is a great tool for management, and it allows you to explore different ecological hypotheses, simulate different climate scenarios, look at how humans will impact the environment, how they will impact fisheries, how changes in land use can affect the ecosystem, and how non-point source pollution can affect the system. So it's a more simplified version of it. This is kind of what we've been working on. So you give the model hydrodynamics, you give the model nutrients, you tell the model how much of the fish is being stocked, and now the part that I created, which is you tell the model what the catch is. You put all this into the model, you ask for different scenarios, and you get an output. And so this can be used to answer some of the questions that we have. This is the map that Atlantis uses for Lake Erie. So this is the Lake Erie that Atlantis knows. It has 38 boxes. The different polygons reflect management units, so like the walleye and the yellow perch management units. It reflects ecological zones and environmental stressors, like the plumes that come in from the different rivers. And we have a lot of boxes in the Central Bay because we wanted to be able to better track hypoxia in that area. This map was created by Kiefer in 2013. So we have 38 boxes and we have 9 vertical layers. So it's a 3D model. This shows it. The majority of the work that I did went from translating the data that I collected from all the different maps that I showed you into a way that Atlantis would recognize it. So I spent a lot of time processing that data in Excel, making sure that we had the date distribution that we wanted, making sure that we had the species that we wanted, separating all the map information into boxes and creating that catch. Once I did all of that curating data in Excel, I went to R and I separated all the data into 38 boxes. Within those 38 boxes, each box has 29 columns for all the 29 species that we're interested in. So I created a total of 1,102 time series that look like this. This is not how Atlantis is going to be reading them, but for the sake of the presentation, I created this graphic. And so when you work with a large data set like this to try and produce such a detailed product, you run into some challenges. My biggest challenges were from data collection and missing data. As you saw from the maps, it's the same lake, but they all use different maps, and that just reflects the fact that they also collect, it's the same type of data, but they collect it in different formats. And and the data is also collected at very irregular intervals, like 3 or 4 different years apart from each other. We also had a lot of missing data. We had complete years that we didn't have. We didn't have monthly distributions. Often the harvest for like the recreational data is reported in number of fish, which it's helpful, but when I care about biomass, I need to know how big those fish were. Were they like 10 little fish or 10 big fish? Because that influences how the model reads these numbers. So with that in mind, I had to make the assumption that the data that we have was representative of the data that we didn't have, and we could use that to replace the missing data. So although I wanted to create a snapshot of how fisheries look like, I had to make that disclaimer that my data is only an estimate of what of the total harvest. And so from that, I have some recommendations. The first one would be to use the same map, use the same spatial resolution. You're working with the same system, and I think that as time progresses and the management units are working with each other, it'll be very important for everyone to be seeing the same thing. I also don't think it's something that's too difficult to accomplish. The second one would be to use the same temporal resolution, especially when it comes to the recreational surveys. So these are surveys that are given to fishermen to complete and then you collect. I understand that it's very difficult to do this on a yearly basis, but if we all agree that we have the resources and that we're going to be doing every 3 years, I think everyone should agree that, well, every 3 years we can all do it on the same year. So that way you create an actual snapshot of how the fisheries look like. And the last one is to collect more biological data. I understand that when people are out fishing, they don't want to know how long the fish is or how much it weighs, but I think that is very important when you're thinking about models so that you can have, again, the biomass, because 10 small fish are very different from 10 big fish. And so with that in mind, the next steps for the project would be to finish calibrating Atlantis. I've also done a lot of the calibration already, but it's a very detailed model. It requires a lot of parameters. It's about 18,000 parameters that need to be changed. I think we're almost done, but more work needs to be done. Once that's finished, we're going to run the model with the different scenarios and answer that question, how might the introduction of invasive species like the Asian carp influence the fisheries in Lake Erie. I'd like to acknowledge my advisors, Hongyan, Ed, and Doran, everyone that I contacted at the different departments of natural resources for their help, to Beth, who's the creator of Atlantis, for all her help, to the summer fellows from the past, Kiefer, Sharika, and Lily. They did a great work building the foundation for this project, to Cody for always helping me when I had questions on R, and to everyone here at UM-CILER for the wonderful opportunity. I think once I left the high school and I really wasn't sure if science was the thing that I wanted to pursue, I think that being here, being surrounded by people who are so passionate about science made me realize that this is the path that I want to follow. So I'm really thankful for everyone's passion for science. Any questions?
So in your introduction, you intimated that the yield for Lake Erie is distributed 50-50 for Canada and U.S.
Not the yield, the total allowable catch.
Allowable catch, but so it looked like Ontario was getting 3-to-1
yeah.
in terms of the actual catch, but obviously that just kept within their target, so it didn't matter.
Right.
We're not doing any carbon trading and
right.
fish filing.
But although there is a lot of contention between the different management agencies and the Ontario agencies, because different nets are used for fishing in Canada that are not allowed in the U.S., so there is some contention about if that total allowable catch that gets given to Canada is fair.
Yeah. And the second question is the harvest based on where the actual fish was caught, or is it based on the license that might have been issued to that?
It depends on the management agency. So that's one of the difficult parts about this data collection. It depends on the management agency and how they process the data and where in the lake they put that, where that was caught. Yeah.
Anyone else?
Does the Great Lakes Fishery Commission do anything to try to open up the they play that role at all in terms of the boxes, the lakes, the up there?
They do for the walleye and yellow perch management unit, just because they're so important. But no, like they all have. I don't understand why there's 10 different grids for the same lake.
Thank you very much.